Screw gauge, most commonly known as the micrometer screw gauge, is an instrument used widely for precise measurement of small objects such as wire. The word screw gauge is used because this device is most commonly used to measure the diameters of the wire, which in turn are governed by standard numbers, which are called as standard wire gauge. The word micrometer represents the principle on which the device works, which is called the principle of micrometer screw. Principle of micrometer screw. When an accurately cut single-threaded screw is placed inside a closely fitted nut and rotated, in addition to the circular motion, there is also linear motion of the screw along its axis. This distance moved by the screw in one complete rotation of the screw is equal to the distance between its two consecutive threads. This distance is called the pitch and is always constant. In this way, the small distances moved by the screw, which are the linear distances, are amplified into larger distances, which is the rotation of the screw. These rotations can be easily measured than the linear distances moved by the screw. Thus, the screw gauge is constructed in such a way that it incorporates the principle of micrometer screw. In addition to the screw and the nut, a U-shaped frame is attached at one end of the nut. This nut, also called the sleeve, has readings on it. These readings measure the linear distance moved by the screw. This scale is called the linear scale or the pitch scale. The other end of the U-shaped frame has a metal projection called the stud. When the screw is moved forward, the stud and the screw together hold the object firmly. The screw is attached to a milled head with a sloping edge which rotates over the sleeve. The sloping edge has a scale which is called as a circular or a head scale. The pitch of the screw gauge is the linear distance moved by the screw divided by one rotation of the screw. To find out the pitch, the circular scale is rotated to bring the zero mark on the reference line. The linear scale or the pitch scale reading is noted down. We count the number of divisions on the linear scale completely uncovered by the cap. Here it is 2.0 millimeters. Now we rotate the screw 5 times. When the zero mark of the circular scale again arrives at the reference line, one rotation is said to be completed. We again note down the linear scale readings after 5 rotations. It is 7 millimeters. We get the linear distance moved as 7.0 minus 2.0, which is 5 millimeters. Thus, pitch can be calculated as 5 millimeters divided by 5, which is 1 millimeter. The pitch of the screw is 1 millimeter or 0.1 centimeter. Therefore, the distance moved by the screw in one complete rotation of the circular cap is 1 millimeter. Now, the circular cap is divided into 100 divisions. Then, if the cap is moved through one division, then the distance moved is 1 by 100th of the pitch, which is the least count of the screw gauge. Pitch divided by number of divisions on the circular scale is equal to 1 divided by 100 mm, which is 0.01 millimeter or 0.001 centimeter, which is 10 to the power of minus 5 meters, which is 10 into 10 power of minus 6, that is equal to 10 into micrometer. In addition, as the least count of the screw gauge is of the order of micrometer, it is called as the micrometer screw gauge. Now, either due to the manufacturing defect of the screw gauge or due to the wear and tear of the screw threads, which gives rise to irregular gaps or increased gaps, the given screw gauge may be subjected to contain the most commonly occurring errors, which are known as zero error and the backlash error. Sometimes in the given screw gauge, when the screw completely touches the fixed stud, the zero of the circular scale does not coincide with the reference line. Then the instrument is said to contain the zero error. When the ratchet is rotated, there is a certain lag in the linear movement of the screw, which is indicated by the jerky motion of the screw. In some other cases, the screw does not start moving immediately in the opposite direction when the ratchet is rotated in the reverse direction. This is due to the improper alignment of threads, which gives rise to increased gaps. This type of error is called as the backlash error. Calculating zero error. In order to find out the amount of zero error the device contains, the position of the zero of the circular or the head scale with respect to the reference line is observed. The screw gauge is turned upright down with its U-shaped frame at the bottom and the ratchet at the top. For example, in screw gauge A, when the zero of the circular scale is to the right of the reference line of linear scale, it can be imagined as if an object is being placed and the screw gauge is already measuring a certain distance, which in reality it is not. Thus, the screw gauge is measuring an extra length, and hence this extra length should be subtracted from the observed length to obtain the actual length. This type of error, in which the zero of the circular scale is to the right of the reference line of the linear scale, is called as the positive error, and the correction we make is negative. Here, in this case, the 11th division of the circular scale coincides with the reference line. Thus, the extra length it measures is 11 into 0.001 centimeters. The correction is minus 11 into 0.001 centimeters. Similarly, in screw gauge B, the zero of the circular scale is to the left of the reference line. The device is measuring less distance than the actual length. Therefore, this distance is added to the observed length to obtain actual length. This type of error is called negative zero error, and the correction is positive. In this case of screw gauge B, the 90th division of the circular scale coincides with the reference line. Therefore, the zero error is 10 into 0.001 centimeters, and the correction is plus 10 into 0.001 centimeters. Now, after determining the least count, pitch and the zero error of the screw gauge, we are now ready to find out the length of any object. Let us say, to find out the diameter of a wire, we place the wire between the fixed stud and the screw by slowly moving the screw with the help of the ratchet until the wire is gently held. The diameter of the wire is nothing but the distance the screw moved from position A to position B. This distance is equal to length of the portion X plus length of the portion Y. As it can be clearly observed, portion X is 1 mm as the scale is graduated in millimeters. That is, the screw has completed one rotation. Portion Y is less than 1 mm because the screw did not complete a full rotation but crossed 31 divisions on the head scale. Therefore, mathematically, for one complete rotation of the screw, the reading is 1 mm. That is, 100 divisions is equal to 1 mm. Therefore, 31 divisions is equal to 31 into 1 mm divided by 100. Therefore, portion Y is equal to 0.31 millimeters. Total length is equal to portion X plus portion Y, which is 1 mm plus 0.31 mm, which is 1.31 mm or 0.131 centimeters. Now, portion X is equal to linear scale reading. Portion Y, N, is equal to 31 into 1 mm divided by 100. 31 is the number of divisions of the circular scale crossed by the reference line of the linear scale. 1 mm divided by 100 is the least count of the screw gauge. Therefore, total reading can be represented as linear scale reading plus n into least count.